So good evening, everyone.
Good evening, ma'am.
Good evening.
Okay. Yes. So I'll be starting with week 6 assignments right now. So last time we had looked at week 5 assignments. Yeah, good evening. So I think people are joining. So and after that, after week 6 assignment, after looking at week 6 assignment, we'll see the R Studio implementation also, as well as um, then we'll have a refresher of some of the things. Okay. So okay. So I'll start with the presentation. So these are like some questions. Okay. I mean, theory you might have seen from the recorded videos. So your week 6 assignments also will be similar. So first we'll look at some how to solve some of these things, and it will be solved in R also. I think a detailed descriptive video of how to solve in R was also given in your pre-recorded videos. So now we'll be looking at some of the assignment questions of the previous run's course. Okay. So the first question was choose the correct option that best describes the relation between variables x and y in the given data. So this is a set of given data, and we have to see the relation between the variables x and y. Okay, so what can you do to see the relation? How do you see the relation between two variables? Can you tell me?
I'm covariance.
Okay, so what I'll do is that I'll go to the R implementation. So just wait a moment. Okay, so this is the question one. Okay, so we were looking at these are the values. So you can just see there are two options actually. You can see a covariance or a correlation. Okay, so if your sample, I mean, if your result is coming as minus some value, then it will be it can be told as these two variables are negatively correlated. If your result is positive, if if you're seeing a correlation. Okay, covariance is one thing, that is right, but the option that, I mean, the thing that best describes the relation between two variables will be correlation. Okay, so in the R Studio, you can check for the correlation using COR. So the result that you get from there, if it's positive, then you can say it's positive correlated. If it's negative, you can say it's negative correlation. So what do you mean by a positive correlation? I mean, if you get the answer as y is positively correlated with respect to x, then what is the meaning of that?
The y value depends on the value of x, and
Yeah.
y is directly proportional to x.
Okay. So as, yeah, you're also right, Kangana. When y increase, x increases, y also increases. If it's negative, then the reverse will happen. Okay. So we'll check in R Studio. Okay. So these are the values: x equal to -2, -1, 5, -5, 2, and y equal to, okay, these are the values. I'll just run the code and we will see for the correlation. Okay, so it's written as -1. Okay, so what will be the answer here? Can you tell me?
Negatively correlated.
Negatively correlated.
Yeah, negatively correlated. The answer will be negatively correlated. Okay, so if you get any set of values, for example, x any values, y any values, so if you are asked to find the correlation, okay, in manual calculation you have certain set of equations. Okay, you have to follow that equation. Okay, that you can refer to your lecture slides. Okay, Imran?
Hello, hello.
Ah, yes.
Madam, whether in the examination we will get the R to run the code or we have to do it manually?
Whether in the,
Whether in the examination, suppose this question is there, can we write the R code there and check it or we have to do it manually?
I think you can run the R also. Okay, that has to be finalized. I think in the exam it is possible.
No, no, it depends. Na? If it's R, we can write it, then it's comparatively easy. Write the code and get the answer, you will get 3 to 4 answers for that. But if it's
I
manually, then
mean,
also it is. So please inquire and inform, please.
yeah, that, yes, I'll have to inquire. Okay. I think it will be there. Okay. So, next one. So, identify the parameters beta naught and beta 1 that fits the linear model. So, using the following information, total sum of squares of x, SSXX is given as this one. Then SXXY is given as this one, and mean of x and mean of y is given. Okay. So since you have gone through the lecture slides, can you tell me, I mean, what is beta naught and beta 1 x that is given?
Intercept and the slope values.
Yeah. So beta naught is intercept, beta 1 is the slope value. Yes. So
The
can you
first
tell
one,
me?
first one.
Yeah. Okay. Yeah. So how did you calculate that?
We just divide, that is SSXX divided by SSXY. Then then the formula is there for covariance. Now one, and that some formula is there. We will just apply it. We will get it. There, it is there in the video only. The formula is there.
Okay. Okay. So I think you are familiar with that. So this is like, okay, so first you have xxxy, then sxxs you have. So with that, what is sxxy?
The difference between x and x mean, summation of x and x mean, and y mean.
Okay, okay. Yeah, I mean, what is it? I mean, summation of
The
difference.
difference
Yeah,
between x and x mean.
so there's a product, right?
Yes, ma'am.
Yeah, yeah. Okay, yeah. So, okay, that's clear. So, SXXY you have as 52.01 and XX is there. So, you just have to give this to divide this divided by this one. Okay, you'll be getting the value of 0.99, and since your y equal to beta naught plus beta 1 x, you can tell right now you are provided with y bar and x bar values. So what you can do is y bar, so your beta naught equal to this y bar minus beta 1 of x bar. So anyway, you have got the answer as a, somebody has told answer as a, so that is fine. Okay, we'll
It
move
is
on to
the
the
simple
next.
covariance. It is the simple covariance.
Yeah. Okay, so the model built from the data given below, is this the third question which was given there? So model given below is, I mean a model was given like this. Find the values of r square and adjusted r square. Okay, so this r square is like a parameter that you can check for finding out what is it for used for, how bad, how good the model is. Okay, first you'll start with the errors, and then you'll check for the r square and adjusted r square. Then maybe you'll check for the residual plots and to see if it is random. Okay, so these all you have seen in the pre-recorded videos. So now we'll go with the R implementation. Okay, because it will be easier to do calculate in the R studio. So Vedant, yes, yes, you, I think you can attend the examinations. Only there will be, even if you miss the first or two assignments, I think you can do that. Just is someone aware of that?
If we'll do it on R Studio, then you can report it manually. Also, you can applying the formula, that is R square is equal to 1 minus summation y minus y bar square and
Yeah, yeah,
divided by
yeah,
some. You can
yeah,
do that one.
yeah. Okay, okay. That is right. That is right, Manmat. No, I was just asking like for the assignments that one of the person has asked. So yeah, you can attend. Yeah. So I mean, you can calculate it like that with using the formula. That is right. Otherwise, what you can do is you can calculate here. Okay, so the question 3, these are the datas. Okay, and the number of the variables, I mean number of observations, n equal to 6. Now then what you can do is, I mean first you should find the all of these things. Okay, like sum of, how do you calculate it? This is just the equation only, sum of x square minus x the whole square by n and syy, like this, and x. This thing I think you are familiar with. So if you calculate this, these are be stored in sxx, sxy, and x sxy and syy. Sorry. Then coefficient of determination r squared. You can calculate by, I mean I'm naming it as SSC equal to syy minus xy the whole square by sxx, and then r square equal to syy minus ssc by syy. I mean this is how you will solve the equation. Later next question we will see how we can calculate it by using some libraries present here. Okay. Okay, so if you run this particular thing, and we will, what you will do is like round the values and print it, round it to two values and print it. So if you do that, you'll be getting the r square value as 0.94. If you round it, it is giving us r square value is 0.95. So can you tell me if this model is a good one, or is it okay? What is the best? What is the best value for r square that you can get?
Near to 1, it is a good fit, and if it is near to 0, it is bad fit.
Okay, so can you stop with r square? What was it that you have seen in the lectures? Okay, yeah, you can't. Yeah. Okay, so what is the bias with r square? Why don't you take r square? Or why do you go for adjusted r square? Yeah.
It gives the variability.
Um, I, I mean, it gives that, but okay, let me see.
I think some residual plots.
No, that is the end. Yeah, that you'll look at later. But what is the difference between r square and adjusted r square? What do you consider there in r square and adjusted r square?
We used to consider the p-value whenever we are dividing it by in the that is called adjusted r square. We are dividing it in the first one, top one, we are dividing it n minus p minus 1, and the lower one, we are dividing it by n minus 1.
Mm-hmm. Okay, just I'll just show you some r squared and okay, it's r square. Okay. Mm, okay, you can just look at this. Okay. Um, so as you said, it is there. So what is the difference between here is like in r square, what is the flow? It never decreases no matter the number of variables that we add to our regression model. Okay. So just wait a moment. Admit everyone. Okay, if you consider number of independent, yeah, this we considered. So in r square, even if you are adding redundant variables to data, the value of r square does not decrease. It either remains the same or increase with the addition of new independent variables. Okay. So adjusted r square takes into account the number of independent variables used for predicting the target variable. In doing so, we can determine whether adding new variables to the model actually increases the model fit. Okay. So that is why we use adjusted r square statistic, and later we'll go for other methods also. But r square doesn't show, I mean, r square has some bias. So we are going for r square adjusted. So r square adjusted value is like 1 minus, I mean, the formula is like 1 minus r square into length of this 1 by length of y minus 2. Okay, I'll just show the formula there. This is the r square formula. Okay, so likewise, if you are trying to implement like that, then you can just show this one. So I have implemented that same formula here. Okay, so this is another way of calculating that. I mean, it's a similar thing only. You'll get the same answers itself. Okay. You can rearrange that formula and get the same answer. Okay. So this is r square and adjusted r square. So the answer is adjusted r square you are getting as 0.93 and r square you are getting as 0.95. Okay. So the answer is coming as A. Okay. So just I have put the code also here. The r square is coming as 0.95. Adjusted r square is coming as 0.93. Okay. So is it okay? So if it's okay, I'll move on to the next one. Okay. Now, the next question is, as you can tell the answer, the linear regression is an optimization problem where we attempt to minimize what of these variables?
Some squared error.
Okay, sum of the squared errors. Okay, so the answer is C. So it's a minimization problem. We tend to minimize the loss function or the sum squared error function. Okay, so minimization of yi minus this whole term is the predicted y. So beta naught minus beta 1 xi the whole square. Okay. Next question. For the following set of questions, use the dataset women.csv. This dataset contains two variables, height in centimeters and weight in kilograms. So this you can I'll just show the data set. This is the data set that we are looking at. Okay, so this many rows, columns are there. So I'll just read this into the RStudio. Okay. So my right now my location. Okay. So if your current directory is the same as the location of your file, you can just put the name of the file itself. Okay. So how you'll see that, if you can just, this was, if you can just type cd, you'll get what is the current working directory. Okay. So if it's not in there, then you can type the whole file path. Okay. So that also I have given. Okay. So what I'll do is that either you can just simply put women.csv if your file is present in your current working directory. If it's not, then you have to type the whole file path. Okay. So right now I have given like this, and what you have to do is you have to read that. Okay, so I think this we had seen, reading the data to a CSV we had already seen in many of the lectures earlier. So I think you had also seen one lecture where you have read, I think which data set, I think one bonds data set might be there, right? So I don't know which correct data set which you have used. Anyway, now we are looking at a women.csv data, and we have to create a model from that. Okay, so what does this LM mean? Can you tell me?
Linear model.
Yeah, linear model. So its formula is like, this is the formula. This is the syntax for that. This is the formula, and this is the data. So data we have read as read.csv. So we'll print the model. Okay. So it will give you these kind of values. So it's showing like, you can check the formula here, whatever you're given. So there is only, your only columns were weight and height. So it's just weight is with tilde sign. So with respect to the height one, and data equal to data. Okay. So this is your dependent value, and the other one is your independent value. Okay. So the intercept is coming as minus 87.552, height is coming as 3.45. Okay. So this is your model that has been created on this data. So what was the question? The first one is, what is the relationship between the variables height and weight? Okay. So the relationship here will be like beta naught plus beta 1 x, right? Yeah, you can tell the answer.
Minus 87.52 plus 3.45 height.
Yeah, that is right. So the answer will be coming as the first one. Okay. So this is how you will do that. Okay. Now the next one is, what is the R squared value? Okay. So for the R squared value, you can just check the model. Okay. If you want to do this like this, you have to like take the set of x and y parameters like this and put the equation in all the x values and y values, and you have to calculate r square like this. So this is okay when your number of variables are, number of columns, number of rows are less. But for a data which is having a lot more rows and columns, it's difficult to calculate manually. So we'll be looking at the, I mean, we just have to run the summary of that model. Okay. So model 1 summary, if I run, this is something that you have seen in your lecture videos. Okay. So residuals, all the quartiles as well as the mean, median, max are given. And then the coefficients, so the intercept and height is coming here. These are the estimated intercept. Then the standard error of that, then t value, t statistics value, and then p value. Okay, so here the number of stars in the p value is 3 stars. So can you mean that, can you tell me whether it is accepted or not accepted? The null hypothesis is accepted or not accepted? Have you gone through the videos of the lecture? So there are certain levels, right? So the p, for the p values. So okay. So if the confidence interval is like 5% confidence interval, then you'll be looking at 0.05, then lesser than that 0.001. So like that, some levels are there. So here what it is showing is that the significance codes for the levels or the t statistic values, if it's not coming, then you'll be rejecting the hypothesis. Okay, so here these values are coming as a very low value. Okay, right now this significance code they have considered is the 0.001, but for that still it is having a very low value, it's not having higher than that. Okay, so it's like you'll be rejecting the hypothesis. Okay, now the residual standard error is given. Okay, then r squared value is given and adjusted r squared value is given.
Ma'am,
Yeah, tell me.
um, so while lecturing, they told that when you have 3 stars, it is more significant.
More
How?
significant of the codes actually.
Yeah. What they mean by that?
Okay, so like this one. So can you tell me what this p value is?
Predicted value.
No, like so you have calculated like this t statistic, right? How do you calculate that? Have you I mean, in the hypothesis testing, we have seen one confidence interval, right? Like 95% confidence interval and all.
Yes, ma'am.
Yeah, so it's like divided in two sides. So if it's a 95% confidence interval, then 5% divided both sides is like 2.5, 2.5. And so your, if your t statistic value or that value is less than, I mean, your hypothesis will be like beta 1 is equal to 0. Okay. So if the p value, so for example, if it's like in one of the lecture videos, I think one of the beta for the intercept, the values had come as point 2, I mean, were higher value, and for the beta 1 value it had come like some point e raised to minus 14, like some value like this. Okay, so it was told like, I mean, for the higher value like 0.02, that one, you can accept the hypothesis. Okay, and for the lesser value, for example, I mean, like here, this is the code used for significant code 0.001. It means that 0.001 means it is the code 0, and if it's like nearby this value, okay, you can accept the hypothesis. But here you can see that it is very slow, I mean the p value is very low. it's like 0.0000. It's going like to the power of minus 40. Okay, so it is not significant. I mean, that value which we have calculated, that hypothesis is not significant in fitting that in the fit of that model. Okay, so the thing is that we will have to reject that hypothesis. Okay, so here it means, is it okay?
Okay, ma'am.
Yeah, you just go through the video once more, that then you can see. Okay.
Okay, ma'am.
Okay, so then we had looked at the r squared value and as well as the adjusted r squared value. Then f statistic, this one in 13 degrees of freedom, the p value is coming as this one. Okay, so the question was like to find out the r squared value. So the r squared value is coming as 0.991. Okay, so it can be got by the summary of the model. Okay, now the next question, it is also based on the same data set 7. So r squared value for the model fitted between is found to be 0.001. You can just check the r value. So is anyone working parallelly in R studio in this lecture? Do you, I think you, so you might not be having the data set, I'm right? Or, okay, Kavi, why have you raised a hand? You can unmute yourself and ask the question. Okay. So we have seen also, yeah, whoever is doing parallelly in R, they can also check. Okay, I don't know if you have the data set with you. If you have, you can do that. Otherwise, parallelly, you can try with whatever data set is available with you. Okay. So, yeah, Adam is trying, I think. Yeah. Okay, we'll move on to the next question. Based on the model relationship obtained from Q5, what is the residual error obtained while calculating the weight of a woman with height 69 centimeters? So this you have to calculate from. Okay, so I'll show you with the equation once and then you can see with the R Studio implementation. So right now what you have got, the result is like intercept minus 87.52 and height is 3.45. So if you have a new for height, I mean, like this is the what you say p1 value. So if you have a new value for that, you have to find out. So right now it's like for a woman with height 69 centimeters, the residual error is asked. Okay, so just it's easy in calculation. So I mean, the if you go to the data set, okay, so about 69, for 69 the weight is given like 150 here. Okay, so this is the data set that is given. This is a reversed actually. Okay, the data set actually there is some problem with when you see it as a um, physical point of view. I mean, like the weight is given as this one, so it's actually should be like weight is this one and height is this one, but um, we are working with whatever is given in the portal actually. So doesn't make much sense, but you can, I mean, if you can change its name and then you can do it. Okay, that's fine. Okay, so here now, depending on that data, it's like we have to calculate the weight of a woman with height 69. Okay, so the entry is like for 69 the weight is given 150. Okay, should be the other way around, but still Now, right now it's like this. Okay. So what you can do is the normal calculation will be like minus 87 point that value plus 3.45 into 150 will be your new weight, and then difference between those weights will be your answer. Okay, so I'll just show you that. So residual error means predicted value minus actual value. So actual value 150 kgs, that is from the data set. Okay, now the predicted value will be like 3.45 into 69 minus 87.51667. So the answer will be coming like 150.533, and residual error will be like this value minus the actual value. So this is this much. Okay. Now, if you go to the R studio, what you can do is this is a, I mean, kind of a new data. It's already present there, but we are still asking like what will be the predicted value when the height is 69. Okay. So first you can do is like you can convert it to a data frame. Okay. And so it's stored in A, and the result, I mean, you can do these whole calculations like here, like predicted value minus actual value, like that. So to get the predicted value, we will use this equation, not equation, we will use the syntax. Okay, predict model 1 is where you have this model created from your data, and A is the input that you're giving. Okay, so if you run these two, now you'll be getting the result. So if you print that, it will be coming like 150.533. Okay, now residual error means this result minus 150, and if you print the residual error, it's coming like 0.533. Okay, so this answer is T. Okay, residual error obtained while calculating the weight of a woman with height 69 is 0.53333. Okay, now the next thing, this you can tell, state whether the following statement is true or false. Covariance is a better metric to analyze association between two variables than correlation. You can put in the chat window the answer for this one.
It's actually correlation should be the answer for true.
Correlation, so actually correlation is a better metric. Okay, covariance is the basic metric that we'll first analyze, but correlation will show you the better analysis. Okay, so because why is it like correlation doesn't have any units? Okay, and it is not dependent on the range of values for the variables. So covariance will have the units, and it kind of depends on the range of the values. Okay, so who was that? Manmat? Okay,
Yes, yes.
yeah,
Manmat.
yeah. So it's like correlation is better analysis. So if you have correlation like a negative one, it is like a strong negative correlation. If it's one, it's like strong positive correlation. Okay. This usually you'll use in many of the.
Excuse me. But I think in the question it should be written clearly that it is a numerical value which is not written. Then only correlation is the best answer. If it is a categorical value, then it will be a problem.
Mm-hmm. So for categorical, how do you do that?
No, for categorical, we have to just grade those with some values with certain ranges. We are assigning some numeric values to those. Then from that only we can calculate the correlations. But directly from
Yeah,
the
yeah.
categorical variable, we cannot calculate. So the question
But
should carry the word numerical.
yeah, yes, yes. So okay. I mean, this is Question is already prepared in the last run course, okay? Is that fine? Yeah, categorical, it's true. But yeah, I mean, it's not written in, I mean, it is was not given in the question there, but it's okay. Yeah. So if R square is 0.6, then the steady state sum of squares of the residuals is 200, and the total sum of squares is 500. Then the error value, SSE value, will be what? Okay, one has told 300. Is it okay for everyone? Yeah, see, yeah. So that is fine only. So the total sum of squares is residuals plus error. So you can find out the sum of squares. Okay. Now there are some little practice questions.
Excuse me.
So
Excuse me.
yeah,
Just go back to the previous question. As here it is SSR and SST is given from the formula that SST is equal to SSR plus if SSC is equal to SST minus SSR, then we can find out it is 300. That is okay. But if we put the R square value and put the equation that is R square is equal to 1 minus SSC by SST, then in that case, SST value we are given, we can find the SSC value as 200 in that case. Check it.
okay. Yeah.
If we are simply calculating SSC from SSR and SST, what is the meaning of R square there?
Mm-hmm. That is right. That is right. Um, but this is like the question. Okay, you're right.
If we take 300, then we are not getting the R square is 0.6. We are getting 0.4 there.
Mm-hmm. Yeah, understood.
Then which one is the correct answer?
Correct answer, you can like just consider, since SSR and SST is given, you can directly calculate with that only. Don't no need to consider the R square.
Okay.
Okay, yeah. So the practice questions. The higher the value of R square for a model, the observations are more closely grouped around. Can you tell me the answer? Is it the origin, the best? Yes, best fit line. Yeah, that is right. So then the next one, the standard assumption of ordinary least squares regression is that, what is the assumption that you can usually see? Is it like there are no errors in measurements of independent and dependent, or there is error only in the measurement of independent? Yeah, C, some has written C. Is it clear with everyone? The assumption is like there are errors only in measurement of dependent variable. Okay, there should not be errors in the independent variable.
C,
Okay,
C only.
yeah. Now, the relationship between dependent and independent variables in a simple linear regression is described by.
F statistics.
Mhm. Any other answer?
Coefficient and intercept.
Yeah. We are asking for the relationship. Okay. So, coefficient and intercept will be the answer. Okay. Assignment 10th question. No, the previous round questions had up to 9 only. Okay. The previous, we are instructed to take the previous run assignment questions. So, the present assignment that you have to solve by yourself. Okay. What is it asked for? If you can just tell me what is it asked for, because I haven't seen the present assignment questions. Okay. Satvik? Yeah, week 6, present week that you are supposed to solve by yourself, because you are evaluated on that. Okay. So after that only we can discuss about that. After its due date. Yeah. We are actually instructed to explain to you about the previous course assignment. So it will be similar. Similar questions will be coming. Okay. Yes. Okay, this was there as a assignment question 2, right? I think, is this the question? 10th question, identify the parameters. I think it's similar really. Is that Satvik? Okay. I think Kavita has posted the question. Is that the question that you are looking for? Okay, yeah. It's already explained. You can see it, okay? Yeah. I mean, this is might be your 10th question now. It was like even like the second question in the previous run course. Okay. Yeah, I mean, some similar questions will be coming from the previous run course. So that is why it's coming like this. Okay, Kavita? I'm not explaining your present question, okay? Present assignment, because that is something that you have to do yourself. So, okay, I think we covered this one and this one also. Okay. You have seen the Pearson's correlation coefficient in your videos. So, it's calculated to be 0.01, zero 0.1. So, what can be inferred from the correlation coefficient regarding the relationship between the two parameters? Can you answer this question?
Point zero means it's weakly correlated, very weakly correlated.
Mm-hmm. Weakly and positive or negative?
It's positive, but very weakly.
Yeah. So there is a weak positive relationship between the two variables. Okay. So that is the answer. Then standardized residuals have, yes, Shiva, that's right, weak positive. So next question. Standardized residuals have,
I think it's the second one.
okay. Yeah, T distribution with n minus 2 degrees of freedom. Okay. So that's right. So I think the practice questions are also over. We'll move on to some R programs. Okay. So this, I mean, you have seen in one of the videos. I mean, you had started with the simple linear regression and one multiple linear regression problem was also discussed, I think. So what you can see here is like I have just created some x and y values, okay? So x is like this particular value, this particular set of values, y is equal to this one, and I am defining a linear model. Okay. So yeah, why have you shared a jam file? I don't know. So this is the R. Okay. So x value, y value, and relation is this much. Okay, so if I run that, then it's stored in x and y and the relation is given. Okay. So a linear model is created with that. Now, if you just want to plot it, okay. So first, I mean, earlier we have just saved that, I mean, read that data and saved a linear model with that and printed it and maybe found a summary. Okay. So here also, I mean, just I will check the summary of the relation model that we have created. So if I run that, it will be giving these many things. Okay, the one which this formula. This is a formula. These are the residuals, and okay, these are the residuals. So the intercept, the x value, then their standard deviation t value, expected value. So here the code taken is 0.01. Okay. Now, yeah. Then the residual standard error, R square value, adjusted R square value, F statistic, and the p value. Okay. Now, if you want to plot, okay, so if you simply want to plot, you can just plot with this one, x value. Then labels also you had defined, right? X label, Y label, all these things. Then main will give you the title of the thing. Yes. Then X label is the X lab. Y label is a Y lab. So I'll be just plotting this one. Okay. So YX column, I mean color equal to blue. Then this is the title of that graph. Okay. Then certain margins also I'll be giving. Okay. So if I plot this chart, it will be coming. So in some cases, so this is the weight and height regression. I'm just giving that this is like height I have given, and this is like the weight. Okay, so here I have just corrected some way. Okay, so this is the distribution. Okay, so what is this AB line doing here? You have seen this earlier in your lecture. What does this AB line do? Oh, you didn't have. Okay. So this is like it will be forming a fit line. Okay, a regression line with respect to the plot. Okay. Yeah. Yeah, kind of. One regression, one fit line. Yeah, that is right. Hmm? So if you just give like that, for example, if you are just plotting like this and checking other values also. Okay. So if you run just this one, you'll be getting this one. Okay, height and weight is there, and you're just plotting the input values and output values. The other one, the AB line, will give you the fit line or the regression line that you had formed with respect to the model that you have created. Okay, so right now the model here is relation here. So if you run this particular thing, you'll be getting that line which will fit the points. Okay, so this you can do in your previous result also. For example, it was given like, okay, this is the model one. Okay, so we'll just copy this one, and in the earlier case it was like, okay, this one, model one, right? So here, then one other thing that we have to change is like right now, X label here is like the height. Okay, because that was given in the file there, and Y label in the Excel value will be coming like the weight. Okay, so now if you, yeah, so if you run this whole thing now, it will be changing like this. Okay,
That height in centimeter and weight should be in kg. Please change.
yeah, that's what I told earlier. Okay, this data set is wrongly labeled. Hmm? It's like weight in kg should have come here, height should have come here. That's right. That's what I told earlier. Okay, but this data set has been given like women.csv in the portal. Okay, so in the question when you are asking, so all the questions were based like that only. That's why the question had been asked here like, yeah, calculate the weight of a woman with height like this. Okay, so the data set is like that. Okay, you can change it. Okay, that is true. You can change the labeling, but that is not idealish all the time. It doesn't make much sense here, like labeling like this one. But when you're given a data set like this, you have to work with that data set. If you change the column names, then you'll not be getting the result that is expected. Okay, so for example, if you had relabeled it as weight and height, and now then you are calculating for asked for a height of 69, it is coming like an outlier. If the height you have labeled as, you have switched the labels, and if you are checking for height of a 69, it's not in the data set, right? It's like some outlier will be coming. Okay, so right now you are given a data set like this, and then you are calculating from what is given in the data set. Okay, is that okay, Manmat?
Yes, yes.
Yeah, that is right. I mean, what you have said is right. It's wrongly labeled there, but since it's given like that, we will work with that data set. Okay. Now, so that's why I took another one. This is you can just expect like these are the height values and these are the weight values. Okay. So this relation is kind of okay. Now, so if now you plot this one, okay, it will be coming like this, weight in kg, height in like this. Okay, then another thing that you can do is like you can save it in some file. Okay, so for wait for a minute. So if I do like this, okay, give the chart a file name. So png, file name equal to linear regression.png. So what will happen is that in the working directory, there will be a file created. Okay, so right now it's showing as 0 bytes because it's just a file which is created. Okay, now you will be plotting the figure and then you'll be saving. Okay, now if you do that, you can come back to the thing and it will be like height and weight regression, weight in kg, height in centimeter, like this it will be coming. Okay, so this is how you can save an image. All right, yeah, so okay, now what I want to do is then another thing is like we'll see the residuals. Okay, so when we saw the relation, the residual standard error is coming like this. Okay, but you have seen in the lecture videos, like I think it was for the Anscombe data, it was shown like some residual plots was shown, and if you have some pattern in the residuals, then it's not like a good approximation in the data. Okay, so now we'll plot the residuals. Okay, so how do you do that is like there is a relation right now. The relation is stored in this particular thing. Okay, this is our linear model named relation. Now the linear model dollar residuals. Okay, so right now for this model, if you give dollar sign, then you'll be getting different values like coefficient, residuals, effect, whatever there is in the summary, it'll come there. Okay, so what we'll do is like to plot the residuals, we'll put relation dollar residuals. Okay, then we will just mention some values, and maybe for example like we will give the x label and y label as required but not needed right now, and we'll give the color as red. So if you do this, your residual relation, so label it has not come anything like that. Okay, that is why what happened here is like it's already given the label as relation dollar residuals. That is the column that we have taken for the y value. So you can see that is there any pattern in these residual values? Can you
No,
tell
no,
me? Yeah, there is no pattern. So can it be accepted?
no, no, no.
Okay. Why can't you accept? Manmat, why can't you accept it? I think you have gone through the thing, right?
It's not at all means those are not at all correlated. It's randomly scattered, and we cannot
Mm-hmm.
take a single. We cannot take a single model to just represent it. So,
Mm,
particularly for that data set,
mm.
it's difficult actually. Will not get a
But residuals, I mean, residuals, you should get like a random value, right? Then only it will be,
no, no, random is
uh,
okay.
yeah,
Random value is okay. But
yeah.
more, we are getting more errors. But if you are just taking some line fit to it, then still also we'll get more residual errors for that.
Mm-hmm. Okay. The thing is like you shouldn't have, I mean, when you plot the residual value, so for example, I think I will uh, show you some values. Okay. Let me show you another example. Okay. So this is like some other data set. Okay. mm, like some temperature data set. So here actually you shouldn't see a pattern. That only you can, if you look at the residual plot, you shouldn't see a pattern from this one. Okay. If you are seeing some pattern, then it is not approximated nicely. Okay. So in this particular example, earlier it was like pressure and temperature. From pressure and temperature, this is the summary of the model. Okay, so this was what the data points were looking like. Now here, when they plot the residuals, okay, it was coming like this value. Okay, you can see now there is a curved shape, there is a pattern. Okay, so the thing is like if you have a more data, the simple linear model will not be able to generalize well. So there is a pattern, here. It's not random. Okay, so you should be aiming for a random plot when you are plotting the residuals, right? So for this, I mean, they have like simply taken, I mean, it's not a very relation for the purpose of plotting and for seeing some randomness. They have just changing the relation as pressure related to temperature and temperature square. Okay, square root of that. Okay, that they have taken. Okay, so just to create some randomness, and the data they have given us the pressure. So now when they are plotting the residual, okay, it's coming like this. So now you can tell that there is some randomness. So if you don't have any pattern in your thing, then maybe you can go for that model itself. That is like what you can see from the residual plot. Okay, now one person had asked for this one. Okay, so there, that for that you can just see the, okay, help, yeah. So for all the things, okay, which is there in the plots, you can see there. Okay, and other graphical parameters, whatever is there in your thing, you can just see. Okay, here. Okay, so I hope the residuals are fine. And also one more thing, whether if you can see. No. Yeah, I'll just post this um, web address there. So from there you can see, okay, you can just see more clearly about the residual plots, right? Okay, so we have seen the plots. So I think I'll share this file and I'll just paste the figure also. Paste the web address. Okay, so you can just refer to that later. And I'll be sharing this. Okay, yeah. So now we will just look on to some uh, I mean, we'll refresh what all we have done with R till now, because then from the next week onwards, right now we had look at linear regression. Then you'll be like progressing in R. Okay, for most of the different things. So we will just refresh some programs in R. Okay. So I think I'll just minimize this. So there is another thing that you will get. Okay, like for example. Um, when you are trying to plot like this, okay, just wait a moment. I think I had stopped for week 5 also. I had stopped with some thing and I didn't complete that, so I'll be taking that now. So okay, wait a moment. So for this, what we can do is like, we will just have a refresher of the things in R. Okay, so um, is there any extra points in your assignments that need to be discussed, or are all the questions similar?
So one question is there where the x and y values are given. Fine.
Hmm.
And one model is given, that is y with some equation it is given 0.2x and 60. And it is asked to
Mm-hmm.
calculate the r square and adjusted r square value.
Okay.
That is one assignment, type of assignment is there.
Is
Which
this
is,
similar to this one? Wait, I'll show you one. Is it similar to this one?
yes, 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 exactly.
Yeah, so you can just see from this. I mean, one method is like you can save it in X and Y, and then you can create some model like that, or you can just solve like what is given using the equation. Any method is fine. Okay, you can refer to this one. Okay, Manmat?
Yes, yes, yes. But madam, still
Okay.
that problem that I said na, that I am still in doubt that R square value is given, SSR, SST is given, it is asked to calculate
Yes, yes, yes. That you can ignore the R square value. Which was that question?
SST. Is it sure? If we'll just put the R square value, then we are getting some different answer for that.
Yeah, yeah. That's an error in the question.
Okay.
Are you having any questions like this now?
No.
Okay, okay.
Whether we will
So,
get the previous means year's assignments or the questions that I asked you yesterday, requested you also, so that you can go for a practice for that before the examinations. That will be better.
no, no, that is not available like that. You can just search for that. You are asking for the previous previous full test, right?
Assignment
Full
questions
exam
also no
question.
issue. Main may not be main questions, but assignment questions, previous assignment questions, sessions.
Yeah, previous assignment questions I'm sharing in the Google Drive. That's what I'm discussing. Yeah,
Okay.
yeah. The main question is not available. Okay, okay, yeah. So just we'll see some. I think I had to discuss with you last time. With cast data we had already seen, so I'll not mention it again. Or I think have I discussed with you ascending and descending orders? Covariance is a better metric to analyze association between two numerical variables. Yeah, I have discussed this, right?
Yes, yes, that is discussed.
Hmm. Aditya, what will be your answer? Okay, Tyagarajan, why have you raised a hand?
Ma'am, I have tried to access the previous year worked assignments. I got only for the previous year. I tried to collect the 2019 or 20th year assignments. I couldn't get. So you have told that it's available in the Google Drive. So will the link will be given in this session, or it will be available in the fourth?
Okay, 2019 assignments is not available to us also. Okay, it might, it's not available to us also. Okay, so I think that you have, yeah, you can mail to the mail ID that is given there. Okay, is it fine,
Okay.
Tyagarajan? Yeah, because it's not provided to us also. For this particular thing, we are providing special, I mean, access to that previous run course. So that only I am discussing with you. The other previous things we are not given access. Okay. Mm, so, Aditya, why do you think it's true? I discussed this. Okay. You just consult the PPT. I'll be sharing this one. Okay, Aditya. So this question is like correlation will be a metametric. Okay. So that answer is false actually. Hmm? Correlation is a better matrix because, yeah, doesn't have any units and it's not dependent in the range of values of the variable. Okay. So we will just see. I mean, sorting. I think I have discussed. If not, you can just. I'll be sharing this week 5 also. Okay. And now we'll just see like some random operations, just like a refresher to this thing. So I am just having a bank data. So right now I have saved it in my desktop. So this is the bank data. Okay. This is a data set. Okay. With so many number of rows. Okay. So like 3000 something rows are there, and these many columns like customer name, surname, gender, age, region, job classification, date joined, and balance. Okay, so we'll just work some simple things with this data set so that it will be helpful for you for your further analysis. Okay, so I'll just read this bank.csv to bank underscore data. So right now it's there as bank underscore data. So right now I'll find out the number of rows. Okay. So number of rows there coming is like 4016. Okay. Then the number of columns similarly you can find out like ncol or ncol. Okay. So if you do that, so bank underscore data, it will give you the number of columns. Okay, so these are all things we have already discussed. Just giving an idea again. Then column names if you want to find. If you do that, you will be getting the column names. Okay, so this is like, these are the column names we had already seen there, customer ID, name. So if you call like call dot names, you can get that. Row names don't have to do, but still if there is some row name, you can print it like this. Okay, this many row names are there. Okay, but it's not having any particular name, so it's not needed anyway. Then we will do some things. Okay, so right now if you just put a summary of the data at this level, you will be getting like this one. Okay, so this is like my customer ID, Since it is a numerical value, it's coming like this. Then the name, it's a character, surname character, gender like this, age, it's a numerical value, balance is a numerical value, so everything in that is given. Then the others are again characters. Okay. So right now it's just shown as a character. Okay. Now we can just check. We will just change the one of the columns as, like, for example, bank underscore data and dollar. Okay. So right now, one thing we can do is this one, or region also, many other things are there. So right now gender, it'll be like there'll be the possibility of either male or female. Okay, so we will do like the same thing that's given there. We will change the gender and we will do this particular operation. Okay, so it will be like encoding a vector as a factor. Okay, so if we put factor, then for the same bank data and dollar, you can choose this particular column. So if you give that, and then after that, if you do a summary of that bank data, you will be getting like this one. So just notice here, it is encoded as these two particular thing. Okay, so earlier it was like gender is a class character and then mode it's given. Now we have separately encoded as two separate things. Okay, all the other things are having many different categories, so that I'm not doing it right now. Okay, many different types of encoding are required. Okay, this is kind of a label encoding. Okay, for example, we are encoding like 0 or 1 to either of the categories. Okay, now sort the data frame by gender and age. This is like some kind of an operation where you will sort the whole data frame in terms of gender and then age. Okay, so I'll just put bank data of order. Okay, and order is like first gender should come and then age should come. Okay, and then everything else. So if I view this particular thing, you can see here. Okay, here the whole data frame is ordered like, first what we have given here, gender. Okay, so female, then it will be coming after after all the female values are over, then it will be coming like male. Okay, because it's like female encoded as 0, male encoded as 1, it's given. Okay, now then the other thing is like bank data of age. Okay, so here you can see for all the male and female, the age also, it's also first ordering is with male, female and male. Hmm? Now then after that it is ordered with respect to the age value. Okay, so age is increasing. Hmm? So the first or sorting of order is with respect to female, and in that itself it's sorted according to the age. Okay, so that is done by this operation. Okay, now show the data for male customers only. So you have right now sorted it. So if you want to see the data for male customers only, then you can just put it like bank data in the square brackets. You can give bank data underscore gender equal to male. Okay, so if you give that, now this will be the only the male data. Okay, only for males. Now if you want to see a separate thing, like for example this whole data had been shown for regions in UK. Okay, England, Wales, Scotland, like that. So if you want to see data only for England, now this is like this one. Okay, so these are the different things you can do with the data. Now another condition, so giving conditions in data, so these all things will be useful in your data initial pre-processing case. Okay, for example, sometimes you might have to get rid of some outliers, or sometimes you want to consider only one type of data or something. So in this you can use this particular thing. So here I'm giving like this column. bank data age should be greater than 40, and another condition, and I'm giving another condition is like bank data underscore gender equal to male. Okay, so if I give this one, then what we are viewing here is that only the ages greater than 40 are shown. Okay, only the data having the age greater than 40 are shown. Okay, now, so this represents and represents or. Okay, yeah. So if I am putting like or, okay, what will be coming? It will be like either any of these parameter. Okay, either it is like the data is greater than age is greater than 40 or the gender is male. So if that also you can do. Hmm? Now I'll close these two. Okay, now another things that you can see is like, I mean, in the summary, you'll get all these things. But if separately you want to see the average of the age, you can calculate by average of the age column, mean of bank data underscore age. Okay. Okay. Then add new columns in the data frame. Bank data underscore dollar interest. We'll select that particular new column. Okay, that column is made from the balance column into point 0.1. Okay, so that you can do like this one. Okay, now, so right now in this data, I think everything is fine. Okay, we'll come back later. Now, if else statement, all you know. So we had seen in the previous some weeks, if one parameter, some will execute some statement, then else some parameters like that we had given the program. Okay. Now there is one condition known as if else. Okay, it's already present as if else. Then test yes, no, like that it's given. So the condition is this one. Bank data balance greater than 50,000. Okay, so if it's that, then we have to interest to column should be like point 0.1 into data underscore balance. If it is not, it's known as yes or no, right? So if it's not, then it will be like 0.08 into this balance. So if I run this particular thing, and if I view, okay, if I view this one, this whole thing, okay, so I'll just view and data. Okay. So it's coming like some new columns are coming here. The interest to column is created with this condition. All right. Now, next one is like what happens if it's NA. Okay. So, for example, just for the purpose of like explanation, age. Okay. So what I'll do is like one of the things in the data, I'll just change as a missing value. Okay, the value is missing. I'm just putting like that. I'm saving it, and just I'm reading the data once again. Okay, bank data .csv. Okay, yeah. So right now that is the bank data. All the things which we have done has changed. Now we are just seeing the mean value. We had already seen the mean value. Okay. So if there is one missing value present in the column. Okay, right now I had removed one thing, okay, here. Okay. And the whole thing, that is only the missing value present. So earlier we had seen the main value and we had got the mean value. Now I had changed one of the entries as missing. Now when we checked, the mean is coming like NA. Okay. So the reason why that has happened is like, okay, the missing value was present there. So what you can do is So right now bank data underscore. So here 1 comma 5 I had given. So this is like 1 0 1 2 3 4, sorry, 1 2 3 4 5 and there, and here 1. Okay, so right now the NA value is present in that particular thing. Okay, so we will just see, change the thing, like right now it's present in NA value is present there in the which row? Can you tell me how do you change this one? The column is right now 1 2 3 4 5 itself, that is right. The row will be, okay, we will just see putting like 3. Okay, so right now if you view this data, you are getting like the third row. Okay, third row is coming as NA. Okay, now so what you can see, third row and the fifth column. Okay, so what you can see is you can just change that data and then you can calculate the mean. So now right now it's okay. Mean is coming as kind of fine. Okay, now this is like just I'm changing it again, so we'll so remove that. Now there is like one other thing. Okay, so you can calculate the mean. So whenever if NA is also present, so for example I am rechanging the value and I am as one of the columns, first column, and then I'm viewing the bank data. So right now the bank data, we have just given this particular statement like 1 comma 5. Okay, so 1 comma 5 is NA now. And now if we want to calculate the mean and remove the other value, NA value, you can use NA.rm equal to true. Okay, so there are two methods. One of the method is like this. So if you're given, there is no problem if missing values are also present. You have to just put NA.rm equal to true. There is another method also, like for example, you can use bank underscore data dollar age or bank underscore data like this age. Anything you can give, and if you do that, you'll get the same value. Okay. Now then just some other statements which we can see, like is NA will show you if whether it is like an NA value or not. Okay. So true and false, yes. Then we will just see the can you update the age column. Missing value should be replaced with average. Okay. So there are some methods which you can do statistically. One thing is like if you have NA values in some of the places, you can replace it with the average of that particular column. Okay, so how do you do is that you will first see if there are any NA values. Okay, so if else is NA, is there is NA in the age column, you will fill it with the mean. Okay, NA.rm equal to true. Otherwise, if it's not there, you'll fill it with the normal age value itself. So if you run this one, okay, if you run this particular code, it will be removing the NA value. And if you view the bank data right now, okay, you can see it like it's changed with the average value there. Okay, so there are that these are some operations that you can do. And so this is like we have just seen some other list. Okay, earlier, like it can store multiple data structures. So these are different things. Okay, like if V is given as this, then matrix as this, and DF is the cast data set given. If you run all these, so I think I haven't run. Wait a moment. I'll just have to store this to cars, empty cars. That is the already given data set there present. So now if I do the list everything here, and when I show this as a list, so you can see here the list contains why have I have shown this is like to just to tell that the list can store multiple data structures. So the first one like was like a vector, the next one like was like a matrix, and the third one is like a data frame. Okay, so all these things can be stored in a list. Okay, so I think most of the things that are needed till now is covered, and there is some other things for data manipulation. So this we will see data maybe. Okay, these are also similar. Anything else? Okay, this all things I think we have seen. Okay, so for what we'll do is like let's stop for today. Okay, anything else you have?
Yes, please get the information that whether we will get our platform to work there in the examination or not.
Okay, okay. Yeah, that I'll ask. You also try. You can try like mailing that in the discussion form.
Okay,
Ask
okay.
in the
I'll
discussion
send.
forum.
I'll
Okay.
send in mail also. But please send.
Yeah. Yeah. Okay then. Okay. So I think for today this is fine for the week 6 assignment. Okay. So can you tell me when you see your um, next assignment submission date?
On 8.
Okay, okay. So I think for this assignment, whatever is discussed will be fine, right?
Yes.
Okay, okay then. So we'll see in the next week, right? Thank you, everyone. Have a nice rest of the day.